Good afternoon, everybody. Um, Continuing our work with topic 11, last time we looked at the idea of moving from ratios to unit rates. Now we're going to look at one of the most common uses of unit rates, which is unit prices. This is how we compare often whether things are a better deal than another, maybe divvying some stuff up so that your friend pays their fair share, things like that. So, just to kind of review, a unit price, just like a unit rate, is the unit rate that shows the price of one item. Okay. Really good about cost information and allowing you to compare costs. And that's really what we'll use it for in any application purposes. Remember, there are kind of two ways to solve this. Now, very specific to dollars per unit, okay, whether it's price per pound, price per t-shirt, um, whatever thing we're measuring, is what order do we put it in? So if it's dollars per unit, you want to have it written this way. Dollars is the numerator, per unit as the denominator, because what we want to do is get the units down to 1. If you end up dividing, which you will for a lot of these, remember that your denominator is going to go on the outside of the division problem. The numerator is going to go on the inside to get your proper division. Since that's such a common mistake, I wanted that written in your notebooks again. Okay, now let's just get into a couple examples and see where, oh, I already knew that, and where what we've learned so far this year will help you with these. The first one is something as simple as I paid $30 for 5 movie tickets. I can't wait to go to the movies again. But $30 for 5 movie tickets. And I went ahead and bought the movie tickets so that my friends and I could all meet at the movies. But I need to know, what is the price per ticket? Now, it will help you if you write this down, because it's going to help you with the order. Okay, what is the price per ticket? So $30 per 5 tickets. So remember, price per ticket. Okay. Well, if I simplify that, and in this case, I could divide by 5 to get an equivalent ratio. I have 6 over 1. So $6 per ticket. Now, here's an argument that I've heard many years in a row. I could do that in my head, Mrs. Atkinson. Why do I have to write that down? And I know I have attitude in my voice. Sometimes you all have attitude in your voice too. It happens. You're right. You can do it in your head. I don't disagree. But can you show me what you were thinking of? And the reason why I want you to show me what you were thinking of is because it does get more complicated down the road. Here's a really common one. It's really common in our textbook, but it's common in real life too. You're grocery shopping and you're trying to find the best deal on something that you like. In this particular case, it's orange juice. Okay, you might like a different kind of juice. You might be comparing prices of lunch meat, who knows? Okay, but in this particular case, it costs $3.20 for a 64-ounce container of orange juice. Please write this down. Okay? And this is on page 371 in your book. We will be doing a lot of practice with this as well. So what we're looking for here, and you'll see I usually use these double question marks, is what is the price or the cost per ounce? Well, that's what we need to find out. And remember I said writing it down would help. So price per ounce, well, that's $3.20 per 64, or divided by 64. Yeah, I don't want to deal with this thing as a fraction. So I can literally just turn it into a division problem. And if we do too many of these, I promise we'll bust out some calculators. Okay. 64 doesn't fit into 3 at all. 64 doesn't fit into 32 at all. Okay. So now we have 320. 5 times 4 is 0. 2. 5 times 6. Oh, look. So all that work we did with dividing fractions, we're going to practice it. If we had 40 of these to do, we would certainly use calculators. If you're doing 2 of them, please do them by hand. Please use that opportunity to practice dividing with decimals so that we don't have to have a whole extra assignment. So what this means is 5 cents per ounce. So that container of juice costs a nickel for every ounce that we drink. Okay? I want you guys to try these, try your try problems, and I can't wait to see you in class.